Hello my dear friends, students, and viewers. This is Sir Palmath and welcome to my video channel. This is the part 2 of our video lesson which we are talking about the multiplication of radical expressions. So let us begin with our learning objectives of this topic. So here are our objectives for today's lesson. So you will be going to apply the different special product rules to determine the products of two or more radicals, and you will be going to simplify algebraic expressions containing the multiplication of radicals using special products. So my dear viewers, so are you ready to learn about the lessons which we are talking about multiplication of radicals using special products? So let us start. So today, you will be going to review what we have learned on the previous video, so which recalling the product of the rules. So the product of the roots known as the multiplication of radical expression. If the value of A and the value of B were real numbers and A and B are greater than or equal to 0, then the nth root of A multiplied by the nth root of B, which is equal to the n root of A times B, or the n root of AB. So in general, the product of the nth root of two or more real numbers is the nth root of the product of numbers. So also, we will be going to review about special products what we have already learned in grade 7 or grade 8 lesson. So these are the following different special product rules. So we have the FOIL method, we have the difference of two squares, the square of the binomials, and the distributive product of polynomials. So let us begin with the FOIL method. So the acronym, the word FOIL means the first, the outer, the inner, and the last. So in every meaning of this acronym, these are the portions of the pairs of factors using the FOIL method. The first special product rule, which is the FOIL method. So the acronym word FOIL stands for the first, the outer, the inner, and the last. So the FOIL method is applicable for the product of two binomials. So we have the first factor is a binomial A plus B, and the second factor which is binomial C plus D. So the product of these two binomials, so we follow the product of the first terms, so which is F, we have AC, so all the first term A and C. Next, we have the outer terms, so the first term in the first factor and the last term on the second factor, so which is A times D equals to AD. Next, we have the inner terms, stands with letter I. So in the middle portion of the product of two binomials, so the last term of the first binomial and the first term of the second binomial, which is B times C. And the last term, which stands for letter L, we have in the last terms of every factor, so B and D. So B times D, which is BD. So that is the formula for the FOIL method, which is AC plus AD plus BC times BD. Okay, next, another special product rule, which is the difference of two squares. So the difference of two squares, which is defined by the formula, so the quantity of A plus B times the quantity of A minus B, so which is expressed equal to A squared minus B squared. So the shortcut method for simplifying the difference of two squares, so we multiply every first term of every factor, so A times A, which is A squared, and then we get the product of different signs, positive and negative becomes negative, and the product of every last terms, B times B is equal to B squared. So that is A plus B times A minus B is equal to A squared minus B squared. Okay, next, another special product, which is the square of a binomial. So this special product has two forms. So the quantity of A plus B squared, which is equal to A squared plus 2AB plus B squared, and A minus B squared, which is equal to a squared minus 2ab plus b squared. So in this rule, the square of the binomial, so a plus b raised to the power of 2, so we get the perfect square of the first term a, so a squared, and then the perfect square of the last term, which is b squared, which will be put on the last term. And for the middle term, so we get the product of two terms a and b followed with the sign and multiply it by 2. So for short, a plus b or a times b, which is ab, then follow the sign positive ab multiply by 2. So 2ab is the middle term. Same with the subtraction. So we have the perfect square of the first term a is also a squared. The perfect square of negative b squared, it's still positive. So same with the first perfect square. So the perfect square of the sum of two terms. And of course, we follow the sign, which is negative on the middle term, and we get the product of these two terms, and it's twice of that. So a squared minus 2ab plus b squared. And last, we will have our distributive product of polynomials. So the distributive product of polynomials, which applied in the form of a plus b times the quantity of c plus d plus e. So that is the product of the binomial and the trinomial. So we distribute the first term of the first factor, which is a, multiplied by the second factor, c plus d plus e. So we have a times the quantity of c plus d plus e, and then we get the sum, which is the second term of the first factor, and we distribute the second factor. So b times c plus d plus e, or we simplify each of these terms simultaneously. So ac, so ac, a times d, which is ad, a times e, which is have ae, then bc, which is bc, b times d, which is bd, and b times e, which is b. So the product of this has 6 terms. So my dear friends, students and viewers, so let's move on to our lesson proper, which we are talking about the multiplication of radical expressions, and that is our part 2 of our lesson, which we will be using the special products. So in order to learn how to multiply radical expressions using the special products, I will illustrate to you some of these illustrative examples on how we'll be going to simplify radical expression involving products. So let us start with the first one. So you will be going to multiply and simplify the following radicals using the different special product rules. As I have already mentioned before, the 4 different special product rules. So let's start with example letter A. So you will be going to find the product of the quantity of the square root of 3 plus the square root of 5 times the quantity of square root of 2 plus square root of 6. So to solve this problem or radical expressions, here is the solution. So to simplify this, the product of these 2 radical expressions, so you will be going to apply one of these special products, which is the FOIL method. So we use the FOIL method. Why? Because in this first factor, there are only 2 radical terms. So multiply by another 2 radical terms. So we use the FOIL method. So FOIL method in the form of the quantity of a plus b times the quantity of c plus d, which is equal to ac plus ad plus bc plus bd. So we will have our given here, and then you will be going to use the FOIL method. So let us begin with the first factor. So the square root of 3 times square root of 2, like this. Next is the outer term. So we have square root of 3 times square root of 6. So square root of 3 and 6, like this. Next, proceed to the inner terms. So we have square root of 5 and square root of 2. So square root of 5 times square root of 2. And last terms, we have square root of 5 and square root of 6, which is square root of 5 times square root of 6. The next step to do, which is we have square root of 6, so we get the product of every terms. So square root of 3 times square root of 2, we have square root of 6, so by the product rule. And then you will be going to multiply square root of 3 times square root of 6. So which is 18. And then square root of 5 times square root of 2, which is square root of 10. And square root of 5 times square root of 6, which is square root of 30. And then, since we have square root of 18, can be factored out. At least one of these are perfect squares. So we have 9 times square root of 2. That is equivalent to 18. So at least we have 9 has a perfect square number. So we get to express into square root value of 9, which is 3. And that is square root of 6 plus 3 times square root of 2 plus square root of 10 plus square root of 30. And that is our final answer. So let's move on to the next illustrative example for letter B. So you will be going to find the product of 4 times square root of 3 plus 3 times square root of 2 and 3 square root of 3 minus 5 square root of 2. So to simplify this product of these two radical terms, so here is our solution. So you will be going to simplify using the FOIL method, so in the same manner as the previous example. So we all know that the first factor has two terms and the second factor is also have two factors. So we use the FOIL method, which is applicable using the formula, so A plus B times C plus D, which is equal to AC plus BD plus BC plus BD. So this is the same manner to do on multiplying two binomials. So follow this, the FOIL method. So we have 4 square root of 3 and 3 square root of 3. So which is 4 square root of 3 and 3 square root of 3. Next is the outer terms. So 4 square root of 3 and 5 times square root of 2. Okay, next we have the inner terms, which is 3 square root of 2 and 3 square root of 3. Okay, so the factor forms. And for the last term, we have 3 square root of 2 and 5 square root of 2. So we will be going to apply each of these terms by product rule. So 4 times 3, so we get 12. Square root of 3 times square root of 3, which is square root of 9. Next, 4 times 5, we have 20. Square root of 3 times square root of 2, which is square root of 6. Then, for the inner term, 3 times 3, which is 9. And square root of 2 times square root of 3, which is square root of 6. And for the last term, 3 times square root of 5, which is 15. Square root of 2 times square root of 2, which is square root of 1. And then, you'll be able to simplify the square root of the perfect square when needed. So we all know that square root of 9, which is equal to 3, and square root of 4, which is 2. So simplify each of this product. So 12 times 3, we have 36. And copy this, 11 square root of 6 minus 30. So 15 times 2, which is 30. And so you'll be going to simplify similar terms. So both constants are 36 and negative 30. So 36 minus 30, so we have 6 minus 11 square root of 6. And that is our final answer. So my dear students, viewers, so let's move on to our next illustrative example number C, or letter C. Find the product of the quantity of 3 plus square root of 8 times the quantity of 2 minus square root of 2. To simplify these two radical expressions, so here is the solution to the given radical expressions. So you'll be going to simplify the product of this. So we're going to apply the FOIL method. So we all know that the given radical expression that we're using the FOIL method, so we all know that 3 times 2, that is first the product of first terms, which is 3 and 2. Next is, we get the product of outer terms, which is 3 times negative square root of 2. So do not forget to bring the sign. And that is negative 3 square root of 2. Okay, next, we have the inner term. So we have the square root of 8 times 2. So we get the product, which is 2 square root of 8. And for the product of every last terms of each factor, so square root of 8 times negative square root of 2. So we have negative 8 times square root of 2. And then you will be going to simplify. So we all know that 3 times 2 equals 6. And then copy the remaining terms. And simplify the last term. So which is square root of 8 times square root of 2. So we get square root of 16. Okay, then you will be going to simplify as possible. So we copy 6, and then we copy also the second term, negative 3 square root of 2, and then plus. We also factor out the square root of 8. So we have at least one perfect square, which is 4. So we all know that the factorization of 8 is 4 times 2. And then we all know that the square root of 16, since 16 is a perfect square, so we get the value which is 4. And after that, you will be going to combine the similar constants, which is the 6 and negative 4. So 6 minus 4, so we get 2. And then copy the remaining terms, 3 square root of 2, and then you will be going to simplify the square root of 4. So it becomes 2 times 2 times the square root of 2. And then you will be going to simplify the last term. So 2 times 2, which is equal to 4. And then combine similar radicands, since we all know that square root of 3 square root of 2 and 4 square root of 2 are similar radicands, so will be combined together. So we have 2 and then plus, so negative 3 plus 4, so larger the positive value, so we get the difference, which is 1 square root of 2 or square root of 2. So the final answer is 2 plus square root of 2. So my dear friends, students and viewers, let's move on to our next example. For letter D, you will be going to find the product of the quantity of square root of 7 minus the square root of 3 squared. So to simplify this product or the square of the binomials that contain radicals, here is the solution. So to simplify the given expression, the quantity of the square root of 7 plus the square root of 3 squared. So you will be able to use the special product using the square of the binomial in the form of the quantity of a minus b squared, which is equal to a squared minus 2ab plus b squared. Okay, so we all know that we follow as the sign, which is minus. So we have square root of 7 minus square root of 3 squared, which is equal to 6a, which is square root of 7 quantity squared, minus twice the product of square root of 7 and square root of 3, so which is negative 2ab, and then plus the square root of b, the last term, which is square root of 3. So we have square root of 3 quantity squared. And then you will be able to simplify this, the perfect square. So square root of 7 squared, which is square root of 7 times square root of 7, so by the product rule, which is square root of 49. And then we get the product also, the 2 times square root of 7 times square root of 3, so which is 2 times square root of 21. And then we have square root of 3 quantity squared, so square root of 3 times square root of 3, which is square root of 9. And then you will have to extracting the roots, so we get the square root of 49, which is 7, and then copy the middle term, negative 2 square root of 21, and then we get the square root of 9, which is 3. And then you will be going to combine similar terms, so we have 7 plus 3, so we get the final answer, which is 10 minus 2 square root of 21. So that is the solution to the given radical expressions. So we get the perfect square of the binomial that contains radical terms. Let's move on to our next illustrative example, letter E. So find the product of these two terms, 3 square root of 3 plus 2 square root of 8, and the three terms we have 2 square root of 3 minus square root of 5 plus 7 square root of 8. So to simplify this product among of these two radical expressions, here is our longest solution. So to simplify this, we all know that the product of the binomial and it's the trinomial that containing 6 terms in all. So by following the distributive property law all over the few terms in the form of the quantity of a plus b times the quantity of c plus d plus e, which is equal to, we distribute the first term by the second factor, so a times c plus d plus e, then plus b times c plus d plus e. Okay, so we all know that we follow as the rule, so we simplify a as the first term, so distributed to the second factor. So we have 3 square root of 3 times, we have the 3 terms, 2 square root of 3 minus square root of 5 plus 7 times square root of 8. Next is the second term, also distributed to the second factor, which is c plus d plus e also. So it becomes b times c plus d plus e, and it follows to 2 square root of 8 times 2 square root of 3 minus square root of 5 plus square root of 8. Okay? So we have the product. So simplify the first set of the terms. So 3 square root of 3 times 2 square root of 3, so like this. 3 square root of 3 times square root of 5, like this. And 3 square root of 3 times 7 square root of 8, like this. Also, we have the blue ones. This multiply distributively the red terms. So 2 square root of 8 times 2 square root of 3, like this. 2 square root of 8 times negative square root of 5, like this. And 2 square root of 8 times 7 square root of 8, like this. Okay, so this is the process of distribution property of multiplication all over the terms, the product of binomial and the trinomial containing 6 terms. So you have to simplify the product of every term simultaneously. So 3 times 2, so we get 6. Square root of 3 times square root of 3, which is square root of 9. Square root of 3, or 3 times 1, so I'll copy 3. And square root of 3 times 5, which is square root of 15. Then 3 times 7, so we get 21. Square root of 3 times square root of 8, which is 24. Also, 2 square root of 8 times 2 square root of 3, so 2 times 2, which is 4. And square root of 8 times square root of 3, which is 24. And then 2 square root of 8 times square root of 5, so we copy the constant, which is 2. And then square root of 8 times square root of 5, which is 2 square root of 40. Then added by 2 times 7, which is 14, square root of 64. Okay, the next process is to simplify square root of 9, so which is 6 times 3. So copy the second term and then combine the green ones. The green terms are the similar radicals containing square root of 24. So that is 21 times 4 plus 4, so we get 25, square root of 24. And then copy the next term, and then we get the square root of 64, so it becomes 14 times 8. So the next process is we get the product of the first term, 6 times 3, which is 18. Copy also the second term, and then we get the possible factors of the radicand, which is 24, to get at least one of the perfect square factors. So we have 4 times 6 has a factor of 24. And then 2 square root of 40, which has a 1 at least perfect square factor, which is 4. So we have 4 times 10, we get 40. And of course, the last term, 14 times 8, which is 112. And then we'll be going to extracting the roots simultaneously. So we get the square root of 4. So we have 2. Also, square root of 4 is also 2. And then we'll be going to simplify the product simultaneously. So we all know that 25 times 2, which is 50, and 2 times 2, which is 4. So that is 130 minus 3 square root of 15 plus 50 square root of 6 minus 4 square root of 10. And that is our final answer. So let's move on to our last illustrative example for this lesson. For letter F, you will be going to find the product of the quantity of square root of 2x plus square root of 3 times the quantity of 2x minus square root of 3. So my dear students, so to solve or simplify this kind of product of these terms, the containing radical expressions, here is the solution. So my dear students and viewers, so to simplify this, we will use the special product rule using the difference of two squares. So we notice that in every first term has similar to every terms. Also we have the last terms. And we have the different signs, positive and negative. So we use the difference of two squares, which has already in the form of the quantity of a plus b times the quantity of a minus b, which is equal to a squared minus b squared. So that is very easy. Use the easiest special products, which is a difference of two squares. So you can simply, we get the perfect square of the first term. So we have square root of 2x times square root of 2x. So we eliminate the radical sign. So we express as exponent, so square root of 2x squared. And then minus, okay, since we all know that the product of these terms, positive and negative, is negative, so minus. And we get the perfect square of the last term. So square root of 3 times square root of 3, we have square root of 3 squared. Next is, we get the perfect square. So we all know that the perfect square of 2x, which is 4x squared. So we get the square root of that, which is 2x also. And square root of 3, quantity squared, so square root of 3 times square root of 3, which is square root of 9. And simplify that, square root of 9, which is 3. So the final answer is 2x minus 3. So my dear friends, students, and viewers, so now you know on how will you going to solve and simplify the product of these two radical expressions using multiplication through special products. So my dear students, that is the end of our video. So my dear viewers and students and friends, so thank you for watching. So please like, share, subscribe, and hit the notification bell at Sir Palmat TV at YouTube channel. So my dear students, friends, and of course the viewers, thank you very much for watching. See you on next video. God bless us all.